Okay, this is lesson 7.6 for 5th grade, a quadrilateral hierarchy. This is basically part 2. We worked on some review in part 1. Remember, a hierarchy is just a fancy word to say like a way we organize certain types of things. And in math, basically we start with a basic category up top, and then we get more and more specific as we work our way down. Previously, with the triangle hierarchy, we started with a group of students in a class, and then we broke them down into categories of students who play sports and students who don't play sports, and then we made it even more specific: students who only play soccer, so on and so forth. So we're going to do the same thing here with quadrilaterals today, and I have a few examples already filled out for you. First, I want you to take a look in the upper left corner and the definition of the prefix quad. We know that una, like a unicycle, means 1. Bi will mean 2, like a bicycle. Tri means 3. And quad in this case means 4. And the things we're talking about 4 sides and 4 angles. So a quadrilateral is anything that has 4 sides and 4 angles. And what you're going to get below is all sorts of different types of 4-sided and 4-angled figures. Now, I want to talk about test property. The phrase test property here basically just means what's the main thing that makes your type what it is. So the main characteristic of a quadrilateral is what we just talked about: 4 sides, 4 angles. Now, the main characteristic of a trapezoid says at least 1 pair of parallel sides. And you might be saying, but how do you know that? Right over here. That's what you're going to use this math message for today. I don't have the quadrilateral cards because we're not in school, so I'm skipping this. But you will use these definitions to fill out your hierarchy. So I literally took the definition for trapezoid, and I took off the beginning because I know it's a quadrilateral. All of these are quadrilaterals. And I just said has at least 2 or 1 pair of parallel sides. And there we go. So you'll notice that things get a little more specific. First, we're just talking about 4 sides, 4 angles. Cool, they can be any 4 sides, any 4 angles. But now we're adding something a little more specific. Now we're saying, well, now we need at least 1 pair of parallel sides, just 1. So how do you think we're going to get even more specific when we go down to the next level? And if you're already looking ahead, now look what happens. When you get down to parallelograms, now they don't just want at least 1 pair of parallel sides, they're saying you need 2 pair of parallel sides to be a parallelogram. And remember, parallel will mean like it's 2 sides that will never hit each other, even if they went on forever. Like if I took my hands, and as weird as it would be if they went on forever, if they're parallel, that means they would never hit each other. But imagine if one hand was like this and the other one was straight, what would happen if they went on forever? Collision. So parallel means they will never hit each other if they went on forever. And you'll notice with my parallelogram, the first lines right here will never hit each other. So that's 1 pair of parallel sides. And even the slanty parallels, they're both slanted, I tried anyway, in the exact same angle. So even though they're slanted, they will never hit each other. Okay, so what you're going to do here is it's going to be your job to figure out how we get even more specific as we go down the line. And what you're going to end up with, this is like a spoiler alert. So if you're not into having things spoiled, I guess plug your ears or mute your computer. You should end up being able to work backward when you're finished. For instance, when we did our hierarchy for students in the class, by the time it was all said and done, you were able to say, oh, so all goalies play soccer, all soccer players play sports. We're talking about like on the playground or in our community. And everyone who played sports on recess was a student in our class. Okay, so that's how it worked out when you work your way backward. And it's going to be the same idea here. When you're all done, you're going to be able to work your way backward, and whatever the definition of square is, you're going to say, oh, cool, well, all squares are rectangles, all rectangles are parallelograms, all parallelograms that's a mouthful, are trapezoids, and all trapezoids are quadrilaterals. So you're going to be able to work your way right back up to the top. It's pretty cool, to be honest. And knowing that is going to help you on page 250 when they want you to answer a few things. For instance, in number 1, they say use the hierarchy. Well, from the hierarchy, you can tell that all trapezoids are quadrilaterals, but not all quadrilaterals are trapezoids. That's true. Some quadrilaterals have 0 pair of parallel sides, and trapezoids need at least 1. So they want you to use the hierarchy to write 2 statements like this. All blank are blank, but not all blank are blank. So the example they gave you was all trapezoids are quadrilaterals, but not all quadrilaterals are trapezoids. And that might hurt your brain a little bit, but it's kind of the same thing here when we were dealing with our classroom. So if we started with kids in our class, and then we only took the students who play sports and made a subcategory of students who play sports, tell me this. If we took half our classroom, literally at our school, if we took the kids who played sports and put them in a group, are they still in our class? Yes. So all students who play sports are in our class. And all students who don't play sports are also in our class. But tell me, is the reverse true? Do all students in our class play sports? No. So sometimes it works one way, but not the other. So in this case, it may be true that all trapezoids have 4 sides and 4 angles, meaning all trapezoids are quadrilaterals, but not all quadrilaterals are trapezoids, because some quadrilaterals don't have any pair of parallel sides. So part 1 here, it's going to be your job to see if you can find another example, something that works one way. For instance, maybe all trapezoids are parallelograms, but does it work the other? Are all parallelograms trapezoids? That's going to be up for you to take a look at and decipher on your own. Another great one, rectangles and squares. Once you look at the definitions for rectangles and squares, this is something that might blow some of your minds. Are squares rectangles? And the easy answer for most people is to say, well, no, squares are squares. But you might find out something different today once you write down your test property and really take a look at what makes a square and what makes a rectangle a rectangle. Okay, that's as far as I'm going to take you here. If you have any questions about the quadrilateral hierarchy, let me know, and I will do what I can do to help you guys out. Until next time, I see you on lesson 7-8 or 7-7. Yeah, I'll do 7-7. All right, see you next time.